Okay, is the mic on? Yes? Good. Thank you. All right. All right. Oh, this is the wrong one. Yeah, we're not grading Exam 3 this week. Exam 3 has been graded and posted this morning, so I have the wrong text up there. We're going to go over Exam 3 solutions today in class. I'm having trouble syncing the Exam 3 grades from Gradescope back to Icon, so they haven't appeared in Icon yet, but I think you guys can see the grades in Gradescope. And regrade requests are open until Friday, so you know how to do that. We'll have Lab 11 tomorrow as usual. Question of the days will resume sometime. Wait, this is the wrong lecture. No wonder it's wrong. What happened to my... Right, let's try this one more time. We'll close that. We'll try this one. Yes. There we go. Exam 3 has been posted. We'll discuss solutions today in class. We're grading homework 2 now. Homework 3 is released today. Will be released later today. It'll be due Friday, May 6th. But I'm going to give you the last weekend for the late period, 75% late period. Instead of 24 hours, I'll give you through the weekend. And Lab 11 will take place tomorrow as usual. Right, let's start with question of the day 16 because that was due before class. I don't think I'm going to give you a question of the day today because you're going to be working on, I'd like you to work or start working on homework 3, at least reading it as soon as possible. So I'd asked you to write a regular expression that recognized a string that looked like a date, and the only requirements were that month and day could be 1 or 2 digit integers, and year is a 2 or 4 digit integer, and they're separated by minus and slash. And what I had in mind was a really straightforward solution where it was just the match to digits and ASCII characters. So let's look at this match here. You remember that the \d is a digit identifier, so 0 through 9. The curly brackets say that there are 1 or 2 of these. Then the square brackets say there are 2 characters in this character class, and there's exactly 1 of them, and it's required because there's no modifier. Again, 2 more digits. Again, it required minus slash, and then 2 required digits plus 2 more optional digits. This would have been fine to solve the solution, and I guess for full credit. The or false is needed because if this expression matches, then we get back a match object. But if it doesn't match, we get back none. And we wanted you to return false, so the or false would then trigger and give you the false that we wanted. All right, so we had some problems with RE match in question of the day 16. The first problem arose the first notice of the problem came up Friday afternoon. So if you read Piazza, you're all aware of what's going on. It turns out that the Python-ish environment that we use in the browser isn't a real Python, and I found out Friday when one of you wrote a note that one of the places where it deviates from the Python-compliant implementation is in regular expression matching. So we had a problem. So I didn't really understand the problem at first. I was dealing with some other issues on Friday afternoon that are departmental business. And so I was kind of in a hurry. I actually had to meet with the dean, so I was dealing with that. So I looked at it kind of hurriedly, and I made the wrong correction. But let me give you what the real problem is. In Python, this RE match and RE search and so on return an object of type RE match. But the Pythonish environment returns an object of type RE match object. Now, it should have been easy to tell this difference. Unfortunately, it isn't because we don't have an interactive Python in the browser. All we have is a Python that can run scripts in the browser. And if you ask Python to print the type of the resulting match object in the browser, you get a blank line. So it doesn't tell you what the internal type is. It took me a little bit longer to sort of figure it out. I had to go, it took an hour or so to figure out what the right object is from the browser. And I didn't get to that until later over the weekend. So my initial correction, which seemed to work, was I noticed that the RE match did not return this object. I thought it might return RE lowercase match object. So I momentarily changed question of the A16 template to the lowercase m, and some of you downloaded the template after it had changed. When I realized it didn't work, I changed it back to the capital M, which works in Anaconda on your Python environment, but does not work in the browser. There's nothing that can be fixed. There's no way to fix this for both the browser and Anaconda at the same time. So if you use the browser, you're screwed. If you use Anaconda, you're okay, or vice versa, but not both. So as it turns out, if you've been following on Piazza, you'll have seen the thread. And it was posted several times, and there was a correction given, and then an explanation for why the correction didn't work. And the real explanation I posted, I think early this morning, when I finally figured out what the problem with the match object was. So, this environment in the browser is very convenient because for quick and dirty things, you can turn something in and test it in the browser, but it's not real Python, and this is the second, I can't remember what the first one was, but this is the second inconsistency between the Python browser and Python that I've found in the 2 years I've been using it, and they're always painful. It's, by the way, interesting how this Python in the browser is implemented. It's actually written in JavaScript. So basically what somebody did is they wrote a JavaScript interpreter for Python in JavaScript so that when you load that page, it downloads this JavaScript code, which is then what actually evaluates Python. What they haven't managed to do is build an interactive Python in JavaScript. This is wrong in so many ways, right? This is a really bad idea in so many ways, but it's extremely convenient when you're teaching to be able to say, here's a file, look at it in your browser, write some code and turn it in. It's fast and easy. And occasionally it bites us. So I apologize for the difficulties that some of you had, but now at least you understand what the deal was. It turns out there's no correction that's possible that will work for both. So in the future, when we start having these problems, I had pinned the notice at the top of the Piazza page. By pinning, it means that everyone saw it first. I can't remember who it was who wrote the note in the first place, but I posted there, download this file and run it in your Anaconda Python environment, and make sure the match is capitalized and you'll be okay, but I don't know how many of you saw that. Okay, so back to our question of the day. This is sort of the bare minimum. It's kind of what I had in mind, but some of you asked, could you do better? And the answer is you can do better for dates. So here's an example of a better regular expression. Here we're going to try to restrict month, day, or year to be more realistic. In other words, we're going to be, I'm losing typesetting here, but this is okay. A slightly better expression will constrain things to be more like a date. So let's take a look at this alternate expression. This alternate expression, you'll notice that we still have the minus and slash here. So the first change, you'll notice we still have the minus and slash here, but now it's in rounded brackets, which makes it a group. And you'll notice that the second time through, right here, backslash, backslash 1, this says that what matches here has to be exactly what matches there. So by making that change, we force somebody who uses slash between month and day to also use slash between month and year. Or if they use hyphen, they also have to use hyphen. You can't use hyphen in one and slash in the other, which we could do in the first solution. So that's the first change, is tying whatever matches here to whatever matches there. And it's a really, really lovely example of why back references in regular expressions can be so useful. The second change you'll notice is that instead of just having 2 digits here, what we actually have is we have a character class for 0 or 1. This is the month, right? So it should be month, day, year. So this is the month, and a month is either is a number between 1 and 12. And so I've restricted this to be either 0 or 1, but I've made it optional because you might want to just give the single digit month. And then I've constrained this to be just a regular digit. So that allows us to be all of the numbers from 0 up to, unfortunately, up to 19, where 7 of those aren't useful, but that's the way it is. Similarly, for dates, we have a 0, 1, 2, or 3, which is optional, followed by a \d. Now this is fine because it lets us represent all the numbers from 0, from 0, which is not a real day, just like here, 0 is not a real month, but it lets us represent all the dates from 0 up to 39, which is a little bit more expansive, but at least it's better than 0 to 99. So you can narrow things down a bit. And then finally, for year, we're going to constrain year to be either a 1, a 2, or missing. So in other words, it's either the first or second millennia or the 0th millennia. And then the hundreds here. These are all optional. Notice the nested optionals in this, and then the 2-digit day here. So this is better. It's not ideal, but it is better. It rules out, 60% of the illegal dates, but it still allows another 40% of illegal dates to be accepted. So the real question is that date handling is really tricky. And can I write a regular expression that handles leap days, leap years, and the difference in how many days per month? Can I write that in a regular expression? And that's an interesting question. Theoretically, I believe it's actually possible because regular expression languages are Turing complete. That means that you can write stuff in that language. Everything you can write in any other language, you can also write in that language. So there's this sort of notion of languages being interchangeable and complete. That doesn't mean that it's convenient to write things in this language or even plausible to do it. I can't imagine a regular expression to do all the intricacies of date processing that doesn't look hideously ugly and isn't completely uninterpretable by a human. So normally people leave these kinds of things to higher level languages. Date processing is really complicated. Aside from leap days and leap centuries and non-leap centuries, because every 400 years you don't get the leap century, or vice versa, I always forget. Pardon me? Did anybody say something? No. So you have a leap year every 4 years, and every century you don't have a leap year, but every 400 years you do have a leap year on the century marker. In addition, there's those 11 missing days when the Gregorian calendar changed. There's all sorts of really complicated stuff going on here. So much so that a relatively well-regarded computer scientist, Ed Reingold, who's I think still alive, but surely retired by now, wrote a famous paper in the 80s called Calendrical Calculations. And in his paper, he wrote code. He came up with an algorithmic interpretation of the calendar that allowed for translation between our calendar, the Julian and Gregorian calendar, the Mayan calendar, the Hebrew calendar, all sorts of different calendars. He took the compendium of calendars and wrote functions that converted from one date to the next. And it's really pretty fabulous paper if you're into sort of like calendar calculations. Even included the Aztec calendar in his group of calendars. So this is extremely complicated. Not something you normally want to do in a regular expression. Questions about question day 16? Anybody? Okay. So now I'd like to spend a little bit of time going over exam 3. So let's see if I can do this in a reasonable way here. Can I close this? Yeah. All right. So first of all, you surely all realize that exam 3 was based largely on lab 10, which you had just done the day before. And in Piazza, I told you guys the best way to review for the exam was to review lab 10, which was an object-oriented program. And I told you we would be doing object-oriented code in exam 3. So let's first start with a quick review of lab 10, which I believe, don't remember if we did. I think there was a feedback form that you got that had the solution in it, embedded in it. But the whole idea of lab 10 was there was a single object, this ZipDrip class, which represented a store that sold coffee. And we set up this sort of initialization function that took the number of perks you needed to get this was the percentage of discount that you got if you were a good customer, and this was the number of cups that you needed to have consumed before you qualified for the discount. So after your fourth cup, you got a 10% discount based on the average cost of your cups bought so far. And then we had this dictionary, which was a client roster that let us register a phone number to a client record, and each record itself was a dictionary. So we had a dictionary in the ZipDrip class that contained dictionaries that looked like this, where you had the phone number as the key, and then you had the number of coffee cups they bought, the total amount of money they spent, this is list price, and then the number, and then there was this sliding window of purchase prices from previous cups. And we went through and implemented a buy method where you bought a cup and it gave your phone number and how much it cost, and then it reported the price you actually paid. And for the first 4 cups you paid list price, but in the last cup, because you've passed that minimum cup, you got a discount of 10% based on 10% of the previous cups that you bought. All right? So here was the implementation, sort of straightforward implementation, which you all saw. The only fancy thing here was keeping things to 2 digits in integers using integer arithmetic. And then finally, there was a status function that printed out how things worked. Now, the key thing that changed in exam 3 is that instead of having just one class, we had 2 objects. We had the ZipDrip class just like before, but now instead of representing the clients as a phone number key and a record and a dictionary record, we had a phone number key and an instance of object type zipper record. Now, if nothing else, this should make you start thinking that, wow, before we used a dictionary to represent different sort of, sometimes they're called slots and fillers or attribute value pairs that describe the customer, right? We had how many cups they bought, how much money they spent, what were the last cup purchase prices they had. So those are values associated with an attribute, which is the key. And now we've replaced that with an object. So it should start making you think, wow, are objects more like dictionary records that are sort of structured, or is there something more to them? And the answer is objects and the records that we used in Lab 10, they're very closely related one to the other. For every attribute value or key value pair in a record, you can have a instance variable and value in the object. The difference, of course, is that with records, you don't have any methods associated with those records, no computation associated with the records. They're strictly data. But when you have objects, you can also associate functions or methods that manipulate those data. And so that was the step we had to take here. But if you were to look at this, we have kind of the same kind of things. Drips and perks were surely were exactly the names of the attributes and values in the record of Lab 10. The one difference is that now we keep track of the last purchase date. And the reason was there's this sad backstory about how the discount was too expensive for management. So now they've decided that you have to have bought a cup relatively recently to qualify. So that's the difference. And what you were asked to do was to come up with a function or method, right, called timeout, that checked to make sure that you had bought your last cup within delta time delta time. And this delta was a time delta object, just like we had in homework 2. So initially, when I create, Ben walks into the ZipDrip cup and buys a cup, he creates his first record by giving his phone number. The time of creation is the original sale time, right? But as later you'll see, as I actually start buying coffee, I'm going to update this time every time I make a new purchase. And that's how I figure out I'm still current. And if I give you the delta, that's a time delta, it tells me, wow, check to see if that guy bought a cup within this amount of time. Because if he did, he gets the discount. But if he didn't, he doesn't get any discount. So that was the key here. So the solution here is not terribly hard. It's, in fact, very much like homework 2 calculations. Basically, you look at, you look at the time now. So this is, I'm asking, did the guy time out? What time is it now minus that time delta, and is that after self.date? Right, so this one says now minus the delta. If it's greater than self.date, then we've timed out. Because he has not bought a cup. He has not bought a cup within the window specified by the current time less that window size, which is the time delta. That's all there is to it. Simple comparison, returns true or false, you're done. All right, so the next question, any questions on the first one? Does it make sense? So remember, like in homework 2, we're dealing with 2 types of objects. There's these date time objects, which contain month, day, year, hour, minute, second, millisecond, if you like. So they have a bunch of different slots in them that specify a point in time. And then we have these time delta objects, which represent durations in time, or in time intervals. And if I want to check if 2 dates are within an interval, I simply take one date, subtract the interval, and see if it predates or postdates the other date. There are in Python date time calculations, there's yet a third type of object called a date object, which is a lot like date time, except it doesn't have hours or minutes, but we haven't dealt with those. You can read the documentation for that. Okay. So now we're going to do the zipper.by method. Now this, in the original Lab 10 solution, the by method was associated with the store class ZipDrip. Right? So ZipDrip represented a store, a franchise, and when you bought something, you sent a message to the ZipDrip and said, buy this. And here, we're associating by actually with the buyer's instance, not with the store instance, but with the individual buyer's instance. So I explained that in the exam, and I believe, let's see, in fact, later you were given this code for the store class and this method, which is the sort of the analog to the Lab 10 by method, and you can see that what this does is it simply finds a cell phone and then sends the by method to the individual zipper object rather than the ZipDrip object. So this kind of dispatching, this is very common in object-oriented code. You send to the organizing collection, you send a message, say, here's what I want you to do. The organizing collection says, that only goes to Ben's object, so it forwards it, that message or a similar message to the Ben object, who then makes the purchase. So this code was, of course, given to you, but even if you hadn't seen it, it explains that the by method is associated with the person. So the question here is, your implementation has to implement the discount timeout policy. We need to figure out how many past purchases you've taken and so on. So all the policy for discount is described. And the discount has also changed. Instead of being a percentage of the average cost of the last cups, it's a percentage of the minimum cost of the last cup. So they're being a little bit cheaper. So here, this is actually the hardest part of the exam, I believe, is this function. And you have to break it down into what has to happen. So here's what I have for this one. First thing I have to do is I have to check the timeout. So in other words, Ben walks in, he wants to buy his cup of coffee. The first thing I need to do is say, well, does he have purchases within that interval? Now, I already have a method for a timeout, right? And I noticed that in the signature of the by class, I'm told what the timeout window should be. So this is passed into me. So I'm going to check if the timeout delta returns true, which means his last cup was long enough ago that he no longer qualifies for a discount, then I'm going to set the number of purchases he's made and the sliding, the window of previous purchases, the last time window number of cups he's purchased. I'm going to flush these right now. I'm going to modify his record, get rid of his number of his drip count, and get rid of the the last purchases, because they're all timed out. They're all too old to matter. Of course, if timeout is not true, then I'm going to leave these guys alone. The next step is I'm going to set the purchase date in his object to be now, because he's buying a new cup. So regardless of whether he has old cups that are still valid, he's buying a new cup, he should get his time reset. I add 1 to the number of cups that he's bought. It might be 0 if his previous purchases have timed out, or if they haven't timed out, it'll be whatever his previous purchases were, plus 1. And I'm going to take the cost of his current cup, and I'm going to append it to this window of perks. So I'm going to keep appending to the end of that list. All his new purchases get added to the end. Now, the key to this window is, understanding this perks structure, is that it needs to contain the last M cups cup costs. So remember, the discount is computed on this number of cups here, M cups. And I want to compute the discount based on the minimum cost cup within the last M cups cups he bought. So let's say M cups is 4, within the last 4 cups he bought. So what I want to do here is I'm going to check if he has more than M cups of these, if he has purchased within the time limit more than M cups of these, then I'm going to update the cost by computing the new discount, which is based on the minimum of the first of the 4 cups that he's purchased. Notice that I'm excluding the new cup I just appended. So there's a little fancy stuff going on here. I need to keep the list cost of his cup in this perks structure, but I need to update the cost to return it. So I first append it to the cost, and I compute the minimum based on the first 4 cups alone. And then and that keeps me just on the 4 cups rather than including the new one. And then I get rid of the first cup. So this pop here always ensures that you only have 4 or M cups number of cups in that window. So this is tricky. And I fully expected this to be difficult for you, because this is why the rubric breaks things down carefully by what you can do. So you would have gotten much partial credit for every part of this that you got correct, but getting all of it is tricky. Other questions here? No? You guys are oddly complacent. All right, so now once we've got the individual buyer class, the zipper class out of the way, we all know how it works, let's turn our attention back to Zip Drive. That should be Zip Drip, apologize. The Zip Drip class, which represents the franchise, the store, right? So think Java House. Much of this stuff looks the same as we had in Lab 10. We have the client roster, M cups and perk. The one difference is we have this delta, which is initializes to a 14-day. This is how many days you have to have bought a cup within the last 2 weeks to get a discount. If you stop buying coffee for more than 2 weeks, your discount disappears. But otherwise, this is very much the same as what Lab 10 was. I even gave you the register class, so you can see how this works. This used to be called register in Lab 10. It's now called client. It checks to see if the phone is in the self.client's keys. This is shorthand for, is the phone number a key of clients? If it's not, then I'm going to add that phone as a key to clients, and I'm going to create a new zipper. Zipper is the constructor for the zipper class, which we've seen before. So this returns a new object for my new customer and associates their phone to my customer. And then regardless, if the phone is in self.clients, then I simply return it. And this will either return the brand new one I've created or the existing one. So this is exactly what we had in Lab 10. This is verbatim. Only the name of the method has changed. So there should be no question here. And finally, this little buy forwarding method that takes the phone number and the cost, says, wow, if the phone here, I'm going to look up the client, and I'm going to send them a buy message with the appropriate values. Now notice, This lookup of the client will actually create a new client if there isn't one. So, as expected. Questions? This is straightforward. So now, in class, before the exam, week before the exam, we spent some time with try and accept. And I wanted to see if you had assimilated try and accept, so I gave you the assignment in here to just use exception handling to rewrite zipdrip.client. And this is really analogous to what we did in class. You recall that the tricky part of the client is this if here that says first check to see if phone is in the client database. If it's not, then you need to create the phone, the new object, because if you try to access a phone that is not in the client database, you'll get an exception, you'll get an error. So that should be your hint, and the solution here is actually pretty straightforward. I'm going to rewrite that else if to just say, look, I want to find out the client object is associated with this phone, just return it. And if this thing fails because the phone is not in the client database, then create it and return it. That's all. So this is exactly what we did in class, verbatim. It simply says, when you have something like this that you're trapping an exception, an unexpected thing, one could see this client method as being the expectation is that every client will be found in the database. But if they're not there, how do I handle that exception? And this is a very clean way to get across to your reader, to the person reading this code, that this is the expectation here is that I'm looking for a client in the database and I'm going to find it. And the accept clause just makes sure that I do find it by adding another client to the database. All right? Questions? All right, so that's the client rewrite. The next thing is a little bit more detailed. We had in the by method, we had a check of the client's timeout. And the check said, if, say Ben, I'm picking on Ben, if Ben didn't fail to buy a cup of coffee in the last time delta days, which here is 2 weeks in our class setup, then what I'm going to do is I'm going to take his list of previous 4 perks and I'm going to zero it out. I'm just going to set it to the empty list. And I'm going to set his counter of how many perks he's bought to 0 as well. I'm just going to wipe out his record. But the issue here is that I'm leaving the object that corresponds to Ben as a client. I'm not getting rid of that. I'm leaving it in the client database. And here, if you think about it, it's a place like Iowa City, people come, they stay a few years and move away. If you never have a way of purging the old clients, eventually your database is going to be filled with people who stopped buying not 14 days ago, but 14 years ago. And so there's a time when you have to get rid of stuff. So this purge method uses the same criteria, because I didn't want to add anything to it, so 14-day criteria, but instead of just simply zeroing out the data in the client object, we're going to drop the client object altogether. We're going to delete it. That's what I wanted it to do. And the cool thing about this is if I do purge a client who's actually just been on vacation for the last 2 weeks, my client method of ZipDrip will actually recreate that object surreptitiously, transparently, without ever noticing. You'll never have that awkward moment when Ben comes in and you say, hey, I can't find your record here. What happened? Right? It'll always just produce a record for me to use in the future to represent Ben. But if he doesn't come back, I don't have that extra record polluting my data. So what I did here is pretty straightforward. I simply rebuilt the client's database. So I used the dictionary comprehension to index the phone and the client's object that corresponds to phone for every phone in the client's key list if they haven't timed out. That's it. Just scan all those objects. If they time out, don't include them. If they haven't timed out, include them. Rebuild that client list from scratch, and you'll have only valid clients in your client list. Questions? Okay, problem 6. Actually, that says problem 5, but it's actually problem 6. Now, I don't assume any of you are married. Maybe I'm wrong, but I've been married 35 years this year, and my wife and I share all our frequent flyer or frequent buyer cards, right? So if Java House has a discount, it's keyed on our phone number, which is obviously shared, right? Because the phone number predates cell phones, so it's been around the same for a long time. And so what would be nice is if we could have a way of sharing that same object between two clients that have different phones. So in other words, it would be nice if, given that my wife buys a lot of coffee at Java House, that when I went in with my cell phone, it would call up her record as well, so that I would get a discount based on her purchasing. You may not care, but let's just say that's the policy. So what I want to do here is I want to add a method to ZipDrip that lets me say, hey, the record that corresponds to phone number old should also correspond to phone number new. Let's just think for a minute what that means in the representation. In the representation of the ZipDrip object, there is this client's value, instance variable, that is a dictionary of phone and object pairs. And what this is asking you to do is to have two different phone keys that point to the same instance of the object zipper. So there'll be one zipper object that's shared among one or more phones, among two or more phones. And all this thing has to do is make that happen. And it turns out that this is really trivially easy. Once you understand what it's being asked, all you have to do is associate phone 2 in the client list with the same object that's associated with phone 1. Now notice the square brackets and the curly and the round brackets. So this should be your clue that there's more going on here. This client here, this is a method. And this method says, given a phone number, return the object that corresponds to that phone number. And this method, as we've seen before because it was written, we've already written it, will always return an object even if the phone number was not in the database. It will magically create a new object and associate it with this phone and transparently return it if it wasn't there. So this thing returns an object of type zipper, and here this is a client, it's not a client, this is the instance variable inside this ZipDrip object, and I'm going to associate the key phone 2 with the same object that's associated with the key phone 1, even if that object's brand new. That's it, one line. At the end of the day, I'm going to return the object that's associated with either phone 1 or phone 2, doesn't really matter. You can return it associated with phone 2 or phone 1 here, it'll be the same object. Is there any questions? Now, I haven't had a chance to look at the distribution of the grades. I did see that the range goes from 3 to 21 or 22 out of 25. So that's a pretty hefty range. Some of you seem to be not ready for this exam in the sense that maybe didn't read the object-oriented stuff, didn't pay attention to Lab 10. Some of you are really quite lost in writing methods. Others seem to take to it much more naturally, and clearly, I mean, how many thought this was really hard? How many thought it was, kind of what you expected? How many of you looked at Lab 10 and when you got there said, this looks just like Lab 10? I mean, most of you got that picture, right? So if you were, my guess is, if you had studied Lab 10 after it was graded and returned to you, you probably did better on this exam than if you hadn't looked at Lab 10. I did warn you, I did say look at Lab 10, it's the best way to prepare for the exam. It's posted on Piazza and I encourage you to do that. The good thing, of course, is that it almost doesn't matter how low the scores are because we grade the class on a curve. So you're really going to see where you rank amongst your classmates. And while you may feel disheartened that your grade is like half of the possible points, if the class average is half of the possible points, then you're just in line with the other students, and the actual grade itself doesn't matter. I will say I was a little bit disappointed in the grades here. I thought you would do better, especially with the hints I gave about Lab 10. But maybe this is just hard. So, Homework 3, which will be released today, will build on this object-oriented notion. In Homework 3, we're going to build two objects. An object called a collection, which represents a collection of presidential speeches. So in the past, I've used the same corpus of, I think there's 200 presidential speeches from all 43. I've got to find Trump speeches because they weren't in the last time I used it. I had to add Obama and Trump speeches. But I have this corpus of speeches, and you're going to read these speeches in using an object called a speech to represent each speech. And you're going to do some text processing. You're going to find, readability indices for these objects. You're going to say this speech reads at a grade 7 reading level. This one reads at a grade 5 reading level. We're going to do some term frequency calculations to find similarity measures between speeches. In the past, I've given unknown speeches that are not attributed to any president and asked you, your code, to say which president most likely gave the speech based on the patterns of language in the speech. I don't know if we'll get to that for this, but we'll do some of this kind of stuff. But I'm spent the weekend rewriting the homework so that it fits in this object-oriented paradigm. Now, I gotta say that CS people are a little bit like ferrets, right? So we like shiny objects. So in the olden days, we wrote machine code, and then somebody came up with Fortran and COBOL, and those were shiny objects, and everybody jumped on that bandwagon. And then after that, we had C and Pascal, and everybody loved C and Pascal. And then, Smalltalk came about, and C++ and Java, and now everything was object-oriented. You didn't add numbers together. You sent messages. Add this to me. Add this to self. It was weird. It's just this. At the end of the day, all of these concepts should be taken with a grain of salt. They are useful where they're appropriate, and mixing these ideas is perfectly reasonable. So you will be writing code, some of it in objects, some of it as functions that will be used as ancillary functions inside the methods. Just to give you an idea of how this code can be organized more in the large. When you get past CS2 and you take CS2820, which is object-oriented software design, you'll talk about how to structure your code, how to sort of design the whole program rather than just function by function by function. In this class, I tell you, write a function that does this. I don't tell you, write a program that does that, because I'm asking you to do specific things, not sort of in the more general sense. And as you advance in your career, you'll rise above the level of designing a program to designing a software architecture, enterprise-wide architecture that has to sort of be the grand master plan for all sorts of software. We're not there today. We're just writing functions and methods. But I do want to give you a little bit more practice with object-oriented code because you will encounter this. Now, I am not personally an object-oriented zealot. I still prefer to write C code than C++. I much prefer it, actually. But I do believe in the organizing principles that underlie object-oriented programming, and I try to enforce those in my own code, even if it's not in an object-oriented environment. There are elements of object-oriented ideas that permeate in the code that I write personally. A really good example of this is this ZipDrip class where we had clients that were represented as phone number keys with records made out of dictionaries. That's the way I would write it. A real object-oriented zealot would do it the way the exam had it. Everything is an object. A cup would be an object. We would create an object that is a cup, and we would send a message to Ben's object saying, buy this. I didn't do that, right? So everything's, within the scope of what's reasonable. But in Homework 3, you'll be able to use some of these object-oriented concepts, and I hope that it helps you at least get some facility with knowing when do you need a self-dot, right? When do I need a self-dot in front of a function name to make it a method? When do I need a self-dot in front of a variable name to indicate that it belongs to this object or this instance of this class rather than just to the Python environment as a whole? And so that's what the homework is trying to get you through. And I will tell you that the lab tomorrow will be related to the homework that comes out today. So in other words, there are parts of the homework that are not in the homework, but they'll be in the lab. So that's what you'll be working on tomorrow. And those are a little bit more interesting algorithmic problems. Okay? Any questions? Okay, we have 4 minutes to do today's lecture, which I actually think is probably not worth it. So we'll defer the lecture until Wednesday. We'll get back to our text processing. Possibly then, since you'll have read the homework, we could actually make our discussion a little bit more relevant to homework 3, so that'll help you out a little bit more. Okay, we'll see you later, and I'll try to get the grades transferred to ICON later this afternoon.